Hello. Practice questions on accelerated motion. Part 2. For each of the particle model in the table below, identify if the velocity and acceleration are positive or negative, and state if the object is slowing down, speeding up, or moving with a constant velocity. So, for the first one, the velocity vector is in this direction, which is positive, and as we see, the object is speeding up because the distance between the dots here are increasing, so the acceleration is in the same direction. So the velocity is positive, acceleration as well is positive, and speeding up. 2. Here, the vector of the velocity is to the left, so we'll consider it negative. And the object is slowing down, so the acceleration must be in the opposite direction, which is positive. So the object is slowing down. 3. The velocity vector to the right and the acceleration is in the opposite direction because the object is slowing down. So here, velocity is positive, acceleration negative, and the object is slowing down. Question 2. 3 objects A, B, and C are moving to the right with different speeds. The particle model for their motions are represented by the diagram below, where the time interval between consecutive dots is 1 second. Complete the table by identifying the object A, B, or C for each of the descriptions below. So, speeding up is B. Acceleration to the left, this one is C as the object is slowing down, so C. Constant velocity, it's A because the distance between the dots are equal, so here's A. Acceleration to the right, that is B because the object is speeding up. Zero acceleration, that's A. Slowing down is C, as we said earlier. B. One of the objects above starts from rest, so that means that V initial equals 0 and accelerates to 12 meters per second, this is V final, in 3 seconds, which is the time. Find its average acceleration. So we just write the formula A equals the change in velocity over the change in time. So that means V final minus V initial over delta t equals 12 minus 0 over 3. So it's 4 meter per second squared. C. Using the SI units, check if the equation x equals half at squared is dimensionally correct. Consider x as the distance, a as the acceleration, and t as time. So we know that x, the measuring unit for x is meter, for a is meter per second squared, and for t is second. So let's write the formula in terms of units. So x is meter equals We don't write the numbers, so we have meter per second squared for the acceleration, and then we have second squared for the time, t squared, so second squared. This will cancel this one, so we have m equals m, so they are dimensionally correct. 3. The particle model for the motion of a disk moving from left to right under different conditions is shown in the table below. The time interval between images is constant. Assuming that the direction to the right is positive, identify the types of motion in each model. So here, let's check the acceleration. Here, in this direction, the object is slowing down, so the acceleration is negative. Negative acceleration. This one, constant velocity, because the distances are equal, so zero acceleration. This one is showing that the object is speeding up, the distance is increasing, so positive acceleration. B. The table below gives the directions of the initial velocity and acceleration for different motions. Complete the table by stating if the object is speeding up, slowing down, moving with constant velocity, or is at rest. So, if both the initial and acceleration are positive, that means that the object is speeding. Here, the same thing, negative and negative, speeding. It's just in the opposite direction. If the initial velocity is positive and the acceleration is negative, so the object is slowing down. The initial velocity is negative and the acceleration is positive, so the same thing, slowing down. Negative or positive initial velocity and the acceleration is zero, so the object is moving with a constant velocity, so constant velocity. Zero initial velocity, negative or positive acceleration, so the object is speeding up from rest. Speeding from rest. 0 and 0, so the object is not moving at rest. Four. On the diagram below, sketch two motions, one with uniform acceleration and the other with non-uniform acceleration using the particle model. So here, if the acceleration is uniform, so that means that the object will start to speed up. That means that the distances between the dots will start to increase gradually, like this. Non-uniform acceleration, that means that the distances will not be equal. So, like this. 5. A car with an initial velocity of 16 meters per second east slows uniformly to 6 meters per second east in 4 seconds. What is the acceleration of the car during this 4-second interval? So again, acceleration equals the change in velocity over the change in time. So V final minus V initial over delta t. That means The final is 6 minus 16 over 4. So that means 10, negative 10 over 4. So it's negative 2.5 meter per second squared. The figure below represents the position time graph for 4 different objects A, B, C, and D. Give a correct description of motion for each of the objects in the table below. So for A, in a position time graph, the object is moving with a constant velocity and it is positive. So positive and constant velocity. B, the object is speeding up, so there is acceleration and it's positive. So we can write positive and accelerating. C is the same like A, so the object is moving with constant velocity and positive. So here positive and constant velocity. D, in a position time graph, D is at rest. E, it moves with a constant velocity but in a negative direction. So it's negative and constant velocity. The biker below started moving from rest with a constant acceleration of 2.5 meter per second squared. A, calculate his speed after 3 seconds. Okay, we just write the formula V final equals V initial plus AT. So V final equals, here we have the initial velocity is 0 because he started the motion from 0 initial velocity. So A is 2.5 times the time, which is 3. So the answer is 7.5 meter per second. B, find the change in his speed between t equals 4 seconds and t equals 5 seconds. Delta V equals A delta t. So the change in velocity delta V equals the acceleration 2.5 times delta t, it's 4 or 5 minus 4, so it's 1. So the answer will be 2.5 meter per second. 8. The graph below represents the motion of a car during a 6-second time interval. A. Calculate the total displacement of the car during the 6-second interval. For the 6-second interval, to get the displacement in a velocity time graph, we need to get the area under the curve. So we have the first area for the first shape, the triangle, this one, and then we have the other area, this one, which is area 2 of a rectangle. So A1 equals half times base times height equals half times the base is 4 times the height is 10 equals 20. A2 equals the base times height equals, here 6 minus 4 is 2 times the height is 10, so again 20. So delta x equals A1 plus A2 equals 20 plus 20 equals 40 meters. B. Calculate the average velocity of the car during the 6 seconds. The average velocity, B average, equals the change in displacement over the change in time. Equals, change in displacement is 40 over the total time, which is 6. So the answer will be, say, 20 over 3. So it's 6.67 meter per second. 9. The graph below represents the motion of a race car during a time interval of 4 seconds. What is the speed of the car at t equals 3 seconds? At 3 seconds, so it's here, we get the instantaneous speed, which is approximately 25. B. Describe the motion of the car. The car is slowing down with a constant rate because the slope is a straight line in the negative direction. So we can write slowing down at a constant negative acceleration or rate. C. Calculate the acceleration of the car. So A, which is the slope, equals delta V over delta T equals, we take any 2 points. So let's say we'll take this point and this point. So here we have 20, which is V final, minus 40, which is the initial velocity, over the difference in time, which is 4 minus 0, so it's 4. So we'll get negative 5 meter per second squared. 10. A train moves from one station to another in 4.5 hours. Its velocity time graph during this motion is shown in the figure below. Describe completely the motion of the train in terms of its velocity and acceleration in the regions indicated in the table below. So for BC, this one, the object is moving with a constant velocity, so the acceleration is 0. So here is constant, and the acceleration is 0. CD, which is this line in blue, increasing velocity or positive velocity, increasing velocity. And the acceleration is positive and constant. So constant, positive acceleration. B. Identify the region or time for the following cases. Train moving with a negative acceleration. So let's get back to the graph. Negative acceleration is dE. Two, train moving with zero acceleration. For zero acceleration, it's BC. Find the maximum acceleration of the train the maximum acceleration is in this region CD because it is steeper, not this one. So we can say we can take 2 points, this point and this point, and we calculate the acceleration. So A for CD equals delta V over delta T, which is equal to V final minus V initial over delta T. So it is 60 minus 20 over half an hour. So 60 minus 20 over 0.5. So it will be 80 kilometer per hour squared. D. Find the distance covered by the train in the last 3 hours. For the last 3 hours, we'll start from this point and then we count backwards 3 hours. So from here to here is 1, and then 2, and then 3. So let's divide this shape into areas. So here we have the first area, which is this triangle, and then we have this area, and then we have this area. So let's start with this area. Let's call it 1. So area 1, which is the area of a triangle, equals half times the base from here to here. So it's 2, 3, 4 and a half, which is 2.5, times the height is 60. 75. Area 2, which is this one, equals half times the base here is half, 0.5, times the height from 20 to 60, which is 40. Then area 3 equals the base times the height. So it's 0.5 times 20, which is 10. So the total distance of displacement equals 75 plus 10 plus 10 equals 95 meters. So the answer here is, as shown, delta x equals 95 meters. Question 11. The diagram shows a runner on a 200 meters circular path. He started and finished at the same point. A. What is the runner's displacement as he started and finished at the same point? So the displacement is 0. B. The runner has a constant speed of 20 meters per second. Explain whether or not he is accelerating. Of course he is accelerating, because here if the speed is constant in a circular path, the direction keep on changing, so the object is accelerating due to changing the direction. So he is accelerating because the direction keep on changing. If we take the vector of the velocity, here we draw a tangent line at any point, so we'll notice that the direction is keep on changing. Thank you.